Okay, plus so another 2 to 3 to go, then we can. It's going to be a short class today. If you so today I done about 4 to 5 we discussed together. Okay, you be a lone ranger now. Try to figure out this. Try to get the 3 formulas. What equals to centripetal force for the location at A, B, and C. A, what equals to mv squared over r, and B and C. Let's draw all the forces acting on that system. And a roller coaster, And a roller coaster here, set here, and the it is here, and stop here. What are the force acting? First, maybe A. What force acting on the roller coaster? Okay. What force acting down? Of course, weight. Acting up. Normal reaction. Yes, normal reaction. Yeah. So yeah, good. The forces acting. So down is mg. Up is normal reaction. So what equals to m squared over r? And the B center going to be normal, and mg is down. The third one, the normal and mg both downwards. Write the formula A, B, and C. At A, what equals to mv squared over r? At A bottom. Yeah, Fn minus mg. Fn minus mg. So mv squared over r. Okay. At B, only Fn. At C, yeah, Fn plus mg. Okay. So now for the discussion, theme park, they build a loop like this. They want to allow a roller coaster into the loop. When they launch the roller coaster into the loop, to the system as a minimum speed, There is any minimum speed required?
Yes.
Yes, there is a minimum speed. If not, it won't achieve the top point. Okay. Maximum speed here not that matter because we hope the track is strong, so never go down.
If maximum speed is so like it rains.
When it comes down, like breaks the track. Whenever so far they never asked about maximum speed in this loop. Minimum speed. Okay, can work out the minimum speed. Which point you consider? V minimum. Consider the bottom, right? Oh, sorry, bottom or top. Consider the top point. Top point. Okay. So when V minimum, then what becomes 0? Yeah, Fn is 0. Good. Normal force become 0. The normal reaction becomes 0. I believe everyone has been to roller coaster. When you go to the top, when you go up, at the top, you have a bar, right? You are hanging upside down. At the top, do you pressing the seat or do you fall into the bar, or like you are floating? No time to think about physics at that moment. So to go again like that. So if you go another round, try to think physics on top. So if the engineer launched the roller coaster at a particular speed, nice speed, the V minimum, I think when you go to the top, you're not pressing the seat. At the same time, you're not falling to the bar. That situation, you experience normal force how much? 0. Okay, normal force means you never press the track, so the track never push you down. Okay, then you started to press the track and you are moving very fast, you push the track. Okay, so when you push the track, the normal force will act downwards. So it's called a special term called what? Weightlessness. Okay, weightlessness experienced at the top. You having weight, but you feel like you are weightless. Okay, you are not falling down. Weightlessness. So the normal force becomes 0 Newton. Okay. So what is the formula then? So top, what do you call the top point C? So mg will be equals to mv squared over r. This is going to be minimum because Fn is 0. So again you get that formula, root of Rg. Root of Rg. You're going to appear in many places. Root of Rg. So V minimum for the roller coaster is root of Rg. Okay. So the engineer must set the speed, measure the R, find the gravity at that point. So R times G is the minimum speed required. Okay. If they put a little higher, let's say V minimum speed for a track, of let's say diameter, let's say the radius, let's say is about 20 meter, let's say it's 10 meter, 20 meter better. It's around 20 meter. So the minimum speed need to be launched is root of Rg. What do you get? 20 times 9.81 square root. How much you get? 20 times 9.81 square root. 2000 wrong. How much? 200. 200 square root. How much you get? 40. 14. Okay, let's say you got 14 meter per second for that loop. But let's say engineer, the technician increase it to 15. So when you go to the top, you press the seat or fall to the bar. You press the seat. Press the seat at 15 meter per second. If not 14, they put it 13.9. Then you're going to fall to the bar. It's very dangerous. Normally they put.
If I'm falling, I touch the bar, that means the car also.
The car also going down, right? It should be clamped or something. Yeah, it's dangerous one. So cannot have 13.9. If this minimum is 14, at least they go more than that. Maybe 14.2 or something. No way smaller. They okay with you to press the seat, then fall into the bar. Okay, but the best experience is exactly 14. You will be floating at the top. But I don't think so. People will. The engineer is going to dare to put 14. Okay, slight different, then no problem. Okay. Okay, now tell me, engineer build this track. You already count the minimum speed is 14, and the passenger maximum load should be 6 people. Okay, let's say 6 people. One day the technician mistakenly, let's say, you overload the roller coaster, let's say, or maybe 6 people, but fat people. The mass is quite big. Any change to the minimum speed? The minimum speed is unchanged. Minimum speed unaffected by the mass of the roller coaster. It's only affected by the radius and the gravity. Okay. So let's say to be more fun, they create one smaller loop, then they make a big loop. Go down. The bigger loop will have a greater V minimum or smaller V minimum. Greater V minimum. So big radius means big V minimum. Okay. So yes, what type of force contribute to the centripetal force in this system? Normal reaction and weight. The normal reaction and weight contribute to the centripetal force for this system. Okay, this is exactly like your string bowling vertically, but the tension was replaced with normal force. Okay. Okay, so this all you need to take down later. When you have faced the notes, you have to write this. Okay. So okay. Now this one. Okay, give it to you. Come on with the formula. What equals to FC? What equals to FC? It's a conical circular motion. You whirl the pendulum like this, it's make a conical. So mj acting down tension is that way. So what equals to mv squared over r? Circular motion is downhill. Yeah. T sine. Very good. T sine theta, right? This is theta, so your maths, this also must be theta. So the tension is diagonal. So the horizontal component of the tension provides a centripetal force. So horizontal component of the tension, you open the angle. The theta open, you use sine. Okay. So T sine theta is your mv squared over r plus equation. Okay. What equals to mg? T cos theta again. As long as the circle is maintained, vertically the net force must be 0. Force up must be same as force down. So T cos theta equals to mg. So this is same like your plane. So 1 divided by 2 will get tangent theta equals to here e squared over rg. Get the third equation. Yes. Unequal formula. Okay. Same like your plane. Plane turning. So here also they're going to ask the same question as the plane. Can the angle become 90? Can you whirl the oscillation until, of course, when you whirl it more faster, angle going to increase. Okay. But can it become like flat? Theoretically. Can it become like horizontal? That means this become like this, straight, horizontal, vertical. Like happened on a flat table, you know. Can happen. But can or cannot? Can 90? Can theta be achieve 90? Theoretically. Physics perspective, by using this equation, physics can say, is it possible or not possible? Not possible. Which equation does that? Second one. Okay. So, second, according to the second equation, the force up, which is T cos theta, should balance the mg, right? But if theta become 90, then this component become 0 Newton, unable to balance the weight. So it can't go 90, cannot go 90. Vertical component of the tension becomes 0. So unable to balance the weight down. So it can't achieve 90. Okay. So in exam they'll ask why it can't achieve 90. It can't achieve 90 based on which formula? T cos theta equals to mg. The vertical component of the tension becomes 0. So unable to balance the weight. Okay, unable to balance the weight downwards. So that way, therefore, not possible. Okay. So when you increase the speed, what happened to the angle? Increase the speed, angle increases, right? Increase the speed, angle will increase. So therefore, the R get wider. What type of force provide the centripetal force here? What provide the centripetal force here? The horizontal component of the tension. Horizontal component of the tension provide centripetal force. Okay. So in exam, there will be many different types of circular motion will be shown to you. You can survive, interpret them. First, identify all the forces acting first. Whatever force acting toward the center minus whatever force opposing is your centripetal. Okay. Okay. Another two systems is not given here. So I'm going to show you. There are many systems now. I have another two systems in my mind to ask you. Okay. So now you're going to interpret that. I just give a very limited information. You're going to interpret everything. Okay. The next one is. Okay. Okay, next one is river. So the engineer built a bridge. Okay, car. Okay, the car is going to the bridge. The bridge radius is R. Okay. The engineer want to write the speed limit. How much the speed limit for this bridge should be in terms of R? It is very limited information. Use your entire circular knowledge. Try to figure out a formula for speed limit in terms of R, the radius of the bridge. But before you calculating your general your imagination, a bridge with greater R or the bridge with smaller R more will have a greater speed limit. Which type of bridge you can move faster? Bigger R, right? Bigger R or small R? Is bigger R the bridge going to be more curvier or less curvier? Less curvier, right? Looks like more flatter. So you can move fast. Okay, speed limit here, speed limit of what? Limit that you never take off. Okay, so a bridge with a smaller curvature or the one more flatter, right? More safer. So big R should have big speed limit, right? Okay, so that's the visualization you should have. You know, physics knowledge or centripetal, the circular motion knowledge. Try to show what is the equation. Find, okay, let's say I put a value. The R of this is 40 meter. Get me what is the speed limit here? How many meter per second? 2 minutes. Identify all the forces, write what equals to Fc, then you can get the answer. Yeah. You have to figure out. Is it a mass of the car? Is it different lorry and car going to that bridge? Do they have a different speed limit? It will be revealed when you form the equation. Speed limit, Important, identify all the forces first step. Second, write what is equals to the centripetal force. Then you can figure out the speed limit. Which position is most likely the car can detach from the surface of the road? That's the point you need to consider. Which point? At the top here, right? Yeah. So you have to consider you have to know that you have to consider the car is like here. This is the point where the most critical point. You might detach from the ground. So what are the forces acting at this moment? What equals to mv squared over r? Find that. How much you got?
More than
Yeah, think about it. It's the time for you to think. 2 minutes, you can discuss with your friend. Yeah? You think mass involved? Yeah, correct. So, no, when you go for a bridge, when you go to a curvature bridge, there is a speed limit. Is a speed limit written for different car, different speed limit? Only once. By the time you go there, you see which car, lorry, or so good that everyone has the same speed limit. Huh? Yeah. So what formula for the centripetal force was? What are the force acting the car at this point? The weight acting down and the normal force acting up. But the circle is which side? The circle is down here. So what equals to centripetal force? Yes, mg minus fn. You can't go fn minus mg. Fn minus mg for the roller coaster. Because the circle is up, the fn is acting towards the center. So fn minus the mg, the opposing force, is centripetal. But this one, the circle is down. So force towards the center should be greater. Mg minus Fn is your centripetal force. Okay, those who get this formula, good. Now, when V is minimum, what becomes 0? Normal reaction. Yes, normal reaction. Once you don't have normal reaction, that means you already detached from the road. You already take off. It's dangerous sometimes. Sometimes, okay. Sometimes fun for you, but it's dangerous. So Fn equals to 0 Newton. Yeah, so mg equals to mv minimum squared over r. So your v, you still get root of rg minimum. So it's root of 40 times 9.81 will give you the speed limit. It will give you the speed limit. So how much again? 20. Okay. It's about 20 meter per second for this bridge. The speed limit must be written as 20. So is this good to give a big value or small value? 19.8 you calculated. So over there, is it good to write 20 or less than 19.8? Less than 19. 20 you take over. So the engineer must write less than, slightly less lah, make it safe for people. So yeah, so cannot be 920 then. So maybe if 19.8, 2 decimal place, then 2 significant figure, then you go for 19 lah, or 19.6 maybe.
So if they would ask this, does that mean that the speed limit is 19.8 or actually below?
Your final examination, 3 significant figure, your final answer. So 19.8.
So it's not like practically we should make it lower.
Lower safer. Lower safer for the people. Right?
Some people would just
yeah, that's their responsibility. If they go speed limit, they are fault. Take off. Okay. So yeah, so the bridge. Okay, so what is advisable for the engineers to build a bridge? Make it the radius greater as possible, so that the speed limit can be increased, safer, more safer. Okay, good. So this is where the circular concept has been used. Okay, another one. I'm going to ask. Mg won't get 0. Gravity, your weight never change, right? Mg is constant as long as gravity is there and it's constant. You won't lose your weight. When earlier I said the roller coaster, I said weightlessness effect. You feel that you feel like you are weightless, but that means you don't have weight. You still have weight, but you don't feel that something is pulling down because of the circular effect. Weightlessness. So weight always there, never change. Weight going to be disappeared if gravity changes. Okay, so another one. Okay, last one. Okay. Another one is the bucket. Okay, a bucket with the water inside. Okay, the water in the bucket is around 20 kilogram. Okay, 20 is quite heavy. Okay, 20 is reasonable.
5 kilograms.
So 5 kilogram. We go for 5 kilogram. Okay, the string is about 0.5 meter. Okay, your friend want to whirl this bucket vertically. Okay, so find the V minimum, so that and when it's whirled that vertically, the water never spill down.
That counts also with the bucket slash.
That's the okay. Assume the bucket is weightless. We ignore the weight of the bucket. Okay, I think good to give the bucket weight, right? Okay, tell me. So the water alone is 5 kg. Okay, the water. Okay, the bucket. Let's say the bucket is let's say 0.5 kilogram. Okay. Go to the top, what speed you should boil it so that the water never spills down. What the minimum speed?
If we consider both, well, since the water is heavy, wouldn't the water fall down first then the water? Or is it because in the speed?
Focus the water. The question is, what speed it must boil so that I think they both will come down.
The boat come down or the water come down because of the mass? Or because the water has more mass, so it will.
Yeah, that's what. Focus to the question is, what is the speed you need to boil so that the water never spills down? So leave it to you. Get what are the force acting, what equals to FC, and find the minimum speed. The water is 5 kg, the bucket is 0.5 kg. So anyone got the answer? How many meter per second? So you need to visualize the top position. You need to visualize the bucket is here. Must visualize the bucket is here. Sorry, it should be on top. So visualize what are the force acting at that moment. So Fn acting down, and mg of the water. We are focusing to the water down. So for the case of water, what equals to mv squared over r? Tension for the bucket. Because we are focusing to the water. We are focusing to the water. The water will start to spill if the normal force of the water is.
Not like we spin the bucket weights.
Because the question is about the water. So the bucket experience tension. Is it the water experience tension? Water experience normal force. Right? So the focus is about the water. So for the water, what is the centripetal force for the water should be? What contribute? Fn plus mg. Okay, this is the formula must come to your mind for the water. So when V is minimum, normal force should get 0. And the water experience the minimum normal force you can attain without spilling is normal force should be 0. The water experience weightless. Okay, like passenger in the roller coaster experience weightlessness. Same thing. Okay. For the roller coaster also, we are not considering the weight of the roller coaster compartment. We just mass the person inside. So here what happened? Mg equals to V squared over R. So yeah, V minimum. So again, you get the same formula, root of Rg. But now, do you need to worry about the mass? Which mass to be used? No one. Mass not involved. Okay. So just the radius and the gravity, 0.5 times 9.81. That's the minimum speed you need to work. Okay. If they ask what is the speed need to boil it for the bucket, prevent the bucket from falling down. If the story is about the bucket, then how's the equation going to be? Tension plus mg equals to mv squared over r. So for the bucket not falling down, again, when V is minimum, tension must become 0. So you get the same root of Rg. It means the bucket and the water are going to come down at the same time. Yeah. Okay, so but focus is for the water, then you have to use this formula. So what is the V minimum? So 0.5 times 9.81. How much you get? Square root 2.21. Okay, now tell me, the person carries a half full bucket of water. You boil it 2.2. The water won't spill down. Now full water. Bucket is full with water. The speed required, same or different? Same, 2.2. Okay. So the mass doesn't determine the minimum speed. What determines the minimum speed? The radius and the gravity. These two determine the minimum speed. Okay, but more massive, you need to have more what? More energy to roll it. You need to have lots of energy to roll it. Because it should have greater kinetic energy. More massive means half mv squared. For zero kinetic energy, to get that kinetic energy, you need the kinetic energy from your body, your strength. You need to give more energy for that body to gain more kinetic energy. Okay. This discussion all are moving with constant speed. Okay. But in reality, if you, let's say you tie the string, you push the object down, it goes up with a constant speed. Because kinetic energy changing to potential energy. So you get speed get lower. Right? In reality, like you are pushing it. Constant speed, when you constantly giving your force, then you can maintain it as a constant speed. But act of nature, you just push it at the bottom, you just let go with a certain speed. You go up with and come to the top, lower speed, right? Okay. So they will ask question like that with changing speed. Okay, changing speed. Let me ask you one question about the changing speed. Where is it? Oh, whiteboard. Yeah, this. Okay, this is L. You see, this length is L. It was moved up to reach the top. Mass is M. Okay, question is, what is the speed required, the minimum speed required at the bottom, so that it at least reach the top? What is the minimum speed required? At least it reach the top. Give the minimum speed in terms of L, M, G. These are the, I think M won't form. So I don't think so. L and G. Give your minimum speed in form of L. I don't think so. M will form. L and G. From well. Think about it. What is the minimum speed required so that it just nice go to the top? and come back down. That means the minimum speed. Speed you need to push down.
How the energy that is converted to potential energy.
Okay, I give you the answer. Prove that the V minimum is root of 5G. Show me, show that V minimum is root of 5G. You have to use conservation of energy. What type of energy at the bottom? 100% kinetic. What type of energy on the top? Potential, 100% potential. Potential and it has kinetic. It has kinetic at the top. It has kinetic, right? It should have kinetic, but if you don't have kinetic, you fall down. It has kinetic. So kinetic, total kinetic energy at the bottom is equals to potential energy and kinetic energy at the top. That will lead you to that answer. Root of 5G. At the top, what speed at least it must move? At top, what speed it should at least it must move so that it never fall down? The VAS should be root of RG, right? But here R is L, so it should be LG. At the top, the speed it should reach at the top at least root of LG. That's what we found earlier. Moving with a constant speed, at the top, the minimum can have is root of LG. So here, when you push it down, when you go to the top, you should have that minimum speed, root of LG. If not, you're going to fall down. So the speed here, you should move at least root of LG. Must be in your mind. Root of LG is the top speed. What is the bottom speed? Can lead to a top speed, root of LG. So point A, point B. So total energy at A must be equals to total at B. Total energy at A, what form? Half mv squared. This is the V we are looking for. Total energy at top is what? mg h plus half mv squared, the top speed, which we know this is what? Root of gl. This h is what? H is how many L? 2L, yes, H is 2L. That's it. So this is the equation must you have. So find the V. So V squared over 2, all M cancels. V squared over 2 equals to 2GL plus GL over 2. Get what? So times 2, you got 5GL. V squared. Then we get this answer. Okay. This is circular motion with not constant speed. act of nature. You throw down, it just because of goes up, potential change to kinetic. So what is the speed required? This one is more practical. Okay. Constant speed. But most of the questions will be constant speed. Okay, so be careful with these two types. This is like real life. Okay. So we're done with this topic, circular motion. Okay. Sometimes can be useful in AS, sometimes we come to circular part. Okay. So on Monday, we'll be discussing the paper. From the bottom, AS trial, try to do the first two papers. I'm going to ask you whatever you got problem, then we just continue that, okay, for 1 week. When you do the paper, please set time, maybe. Objective, 1 hour, 15 minutes. Structure, 1 hour, 15 minutes. Both are 1 hour, 15 minutes. Okay, set time and do the paper. Okay, so thanks.